Hi everyone. Another problem that was requested to me that I troubleshoot this week is problem 939. This is the problem using Bayes where you have to figure out what percentage of the cars with problems go undetected. Alright, so this student, again, she's got a good structure to her Bayes. She got most of the she got the steps in Bayes. She got matched, she multiplied, she added, and she divided. So let me go through what she's done really well. So she got her inverses really well. So the number of inspected cars that has problems and fails to detect is 12%. The inverse of that is that they have problems and the problem is successfully detected is 88%. And then these are also correct. So no problems fails to detect 100 times. So no problems detected is 100%. And they don't ever detect problems when there are no actual problems. So, all right. And then the other number that's important is that there are, and she got this inverse right as well, that there are 18% of the cars with problems, 82% of the cars have no problems. All right, so now let's go over what she did here, which was also, I think this was solid. We will continue troubleshooting in a moment. But she did have problems, and she multiplied that number by the odds that they fail to detect the problem. So she did the percentage of the cars with problems times the percentage of the cars that have problems and fail to detect. So that's a good multiply. Then she did cars with no problems and fails to detect the problems. So this is no problems, fails to detect, so that's 100. And then because they have no problems, and you multiply that by the 82. This one is has problems, successfully detects the problem. So has problems and then has problems, successfully detects the problem. Okay, so that's where those two numbers came from. And then this one was no problems. So no problems and detects problems. So this should actually be down here for no problem and detect problems. So did we get this one right? So has problems, 18%, yes. Okay. So that was one mistake. This one didn't affect her outcome because this number is 0 anyway, so it really didn't matter whether she multiplied by 18% or 82%. It was still going to be 0, but the correct way to do it is to multiply by 82% with the no problems. Okay, now, this next section is actually where there is a problem with this. She did the right thing in adding, but she didn't add the right set. So what you do here is you're not multiplying the outcome here, you are multiplying the odds of detecting a problem or not you're adding the odds of detecting a problem or not detecting a problem. So let's do this. Let's do detect problem and does not detect problem. All right. So has problem successfully, okay, so we've got to change these two. So we need to go to the two that successfully detects the problem. Actually, that was the two she had, wasn't it? Yes, okay. And then does not detect problem here, that's going to be these top two, so fails to detect, and actually that's probably a better label. So fails to detect. All right. All right, I think down here, there may be a labeling issue that helped confuse. So I always like to make sure I use very consistent labeling throughout this MAD process. It really does help. If I don't use consistent labeling, I can confuse myself, and I understand this stuff pretty well. Okay, so on this top, we're going to do has problem, okay, and has no problem. So these are our actuals. And then here's our prediction. So detects problem and fails to detect. All right, so now let's look at these. So B16, okay, should be has problem and detects problem. So has problem, successfully detects problem, yes. And then dividing that, yeah, you know what, something's not right in this labeling here still. All right, so this is fails to detect, okay, and no problems, detects problems, okay. Yeah, so actually, yes, that should be 1. So that is correct. All right, so now B14 has problems, fails to detect problems, and then you multiply that by fails to detect, or so you divide, not multiply, this is divide. You divide that by the fails to protect. All right, so that's where you're getting this 0.0257 number, okay? And this is actually the number that you're looking for. All right, so now let's go ahead and fix these. So actually, we'll just make sure it's correct. So successfully, or so has no problem and detects problem, no problem, detects problem, and then this actually needs to be divided by detects problem right here, okay? It's still 0. All right, and so has no problem and fails to detect, so has no problem, fails to detect, so that's no problem, fails to protect, so that's right, and then B21 fails to detect. Yep, so that should be right as well. And our checks are telling us that these two are right, so these two should sum to 1, and they do. So this is now correct. And again, the issue was just, I think in the labeling down here was the biggest issue. And then it didn't help that this labeling wasn't quite right either. So again, I hope that that helped. I hope that that helps the rest of you. Again, this student had a super solid structure to this, just made a couple of little mistakes that kept her from getting quite the correct answer, but it was a really good attempt. All right. Again, if you have any questions, please go ahead and reach out to me. I am available to you, want to help you. Let me know. Thank you.